All right, here we go. Okay, here it is. Example 6. Use intermediate value theorem and Rolle's theorem to prove that the equation has exactly one real solution. Okay, what I'm going to do is call this f of x, first of all. And I'm going to notice, just kind of randomly pick these two numbers, -1 and 1. And I evaluate, and I realize this one's negative, that one's positive. That means because of the intermediate value theorem, function takes on every value between -2 and 4. Because the intermediate value theorem says that if you have a continuous function on that closed interval, then the function takes on every single value between -2 and 4. So there must be a place in there where f of x equals 0, somewhere between those two. Okay, so that means there's at least one place there where there is a 0 there. So now assume that there's more than one. Okay, assume the first one is at x equals a. We know that's in here somewhere. And then assume that there's another one someplace. I don't know where it is, but we're assuming that there's another one where f of b equals 0. Okay, now by Rolle's theorem, there must be a value c between a and b such that f prime of x equals 0, or in other words, f prime of c equals 0. Now, so let's go ahead and try to find it then. Well, take the derivative of the function f, and you get this. And you try to set it equal to 0, because that's what it's supposed to be. And when you do that, you realize, wait a minute, I can't solve this. This left side here is all positive. Okay, it's positive. It can never be negative unless you try to use imaginary numbers. It's never going to be 0. Okay, because this will always be positive. This will never be negative. This will never be negative. So you'll never be able to add positive numbers together to make a 0. So there are no. That's not going to exist then. So if that's a contradiction, then something must be wrong about our assumption. And that only assumption was that there was a second 0, second root here. That means there must not be. And that means there must only be one. That's the end of that. There's only one.